table standard integrals we're using. Normally, integral calculus, constant multiplier, sum, and subtraction to find what's called an indefinite integral, and the use of integration to evaluate what's called definite integrals. We may get all that done today. Okay. Next week, Peter, I mean next teaching week. Alright? Which is 3 weeks from now. From today. So, the process of integration is a mathematical reverse of the process of differentiation. Then the first differential of that, and you all know how to do that now, you multiply by the old index 2 to make 4, take 1 off the index, 4x to the 1, which is 4x. Okay? If integration is the opposite, the integral of 4x must be 2x squared. So if we was to integrate the function we've differentiated, we end up back where we started. Okay? Mathematically, the integral is written like that. That's the integral dx. That means the integral of 4x x to x. That means the integral of 2t with respect to t. Yeah? Okay, so that's the mathematical, and that's the symbol. I've never come across that symbol before, or seen it but didn't know what it was. That means the integral of. Alright? From the previous page, so on the next slide, from the previous page, we know that if a function of x is 2x squared, then first differential is 4x, and therefore the integral of 4x is 2x squared. Now look at this. If we differentiate 2x squared plus 7, we still end up with 4x. Yeah, the constant disappeared. When we integrate, we go back to 2x squared. Completely different function. This and this, completely different functions with the same integral. Well, the same differential, sorry. Going back to 4x. Okay. So if we take the integral of 4x dx, that could also be 2x plus 7. Or if we started with 2x squared minus 6, could be that. The point I'm getting to is constant 7 could be any number. So when we take the integral of 4x, we have to add the arbitrary constant of integration. Because we don't know what it really was. Yeah? C is called the arbitrary constant of integration. C cannot be found without additional information about. So if you've given boundary conditions to enter into the function that you've integrated, you can then rearrange that and perhaps find the constant of C. But if you don't have that, then the constant of integration is there. And if you're doing indefinite integrals, which these are, if you leave the constant of integration off in your answer, then you're going to lose a mark. Because it is important that's there. Alright? So, the easiest differentials to deal with were those of the form ax to the n. Yeah, and it's similar with, although sine and cosine ones are not that difficult either. But the general solution of the integrals of the form ax to the n dx, where a and n are constants, are given by that formula there. And that's what you've got in your table. If you've got a function that's ax to the n, what we do is add 1 to the index on the top there and divide by the new index. So we take it as, if we take this one, we're doing the integral of 3 x to the 4 dx. That equals, the 3 stays, and we'll come on to constant multipliers in a minute. Okay, we've got to add 1 to the index and divide by the new index plus a constant of integration.
Why are you not adding the 1 as well? Divide by 0 and x plus 1.
No, n is the old index.
Oh,
N is n.
Oh, you've already added 1 on.
So it's 1 on to 4.
okay.
Yeah, and divide by that new index.
Oh, you put this plus 1 on both parts.
Yes. N is what is the index that's in the original function, Peter, yeah? And 1 to on the top, and also divided by that index, which is n plus 1.
Okay.
Yeah?
So that'd be 4.
No, you can't what, calculate anything because you don't know what that constant is. That's the answer, Kieran. The answer to the integral of 3x to the power 4 dx is 3x to the 5 over 5 plus a known arbitrary constant c. Alright? What about this one? I'll put it down in there. Integral of 2 over x squared dx. What do we normally have to do that are underneath? Yeah. Have to go equals the integral of 2x to the minus 2 dx. Bring it into that ix to the n form. Put that question down there for a minute. So to finish that off, keep our 2, x, add 1 to the index, minus 1, divide by x.
Use the
One over x No, that's a special case, and we're one over x. That's where we come to with this question in a minute.
I'm just looking at the force rule down.
Yeah, yeah. You could write. I'm coming on to that in a minute. All right. But if you apply ax to the end to that, you get a problem. All right. Look, we'll be there in a minute. Lastly, about the integral of square root of x. How can we rewrite that? Of x dx. Now we apply, so it's x, 1 to the index, divided by. So write that. That's what it is. All plus c. The denominator divided by 3 over 2 plus c. Want to turn that into 1.5. Resolve 2 divided by. You could write that fraction x cubed squared. All right. Want to divide one fraction, you turn the denominator fraction upside down, multiply. That's equal to square root of x cubed. 2 it's the most. All right, but there. All right. In that particular case, it x to the power of 3 over 2 over 3 over 2 plus c. Yep. And the fact is, if you had a value of x and you wanted to know what it is equal to, if you put the numbers in that and put it in your calculator, you get the right answer. But that is the simplest form. Right? Right, this thing about n being minus 1. The function 1 over x, and we want the integral, and a special in it's the case. We could, like we did, we'd write that as the integral now dx the rules, so 0 what's the 0 1 divided by 0, do that. 0. There's a in your cover X. Times X. Get a square of the cube back. Happy? Right. What we have a look at now, there's another couple of examples. Well, we'll just check these ones by differentiating back and seeing if we end up back where we started. Right, so A, integral of 5x dx. So in terms of, if we integrate, what's that equal to? 5x cubed 3 plus c. What do we do when we differentiate? We cancel. Oh, hang on, we got lost our x in there. Be in there. 5x squared. When you different, just neaten that up a little bit, because you're going 5 over 3. When you differentiate, these two cancel. What we started with, 5x squared. So differentiate. Go at the next one. Integral of 2 times t to the power 3 dt. Right.
Equals to 3.
Well, yeah.
And then 2y by
Yeah, how else could I write that? 2 over 4. Now if you differentiate that, dt, we'll call it y, dy by dt is equal to 4 times 2 t to the 3 c cancels, so we end up with 2 t to the 3, which is what we start with.
I see in that.
Oh,
No. Wait,
with blue.
where we put blue? dy I see and then
You're differentiating, and this is y is equal to. Yeah, because if you integrate that y by dt, you end up with y. That's the process. Y up with that. If you say y equal to the integral of that, there's the function diff dy. Right? On your sheets, you've got the standard integrals for all the functions that you've had standard derivatives for. So there's a constant. Yeah, there's ax to the n. So this first one suggests if we the variable comes back, the x comes back, we get ax plus c. Yeah, we'll look at one like that in a minute. Okay. We've got an entry for ax to the n, which is the one that we've been using. Note that it says n must not equal but minus 1, and we've already looked at that issue. Where n is minus 1, we're looking at this version. The integral of 1 over dx is ln x plus c. We've got an entry for the x e to the power of ax. We can divide by a, leave e to the ax in there, and add a constant of integration. Sin ax is minus 1 over a cos ax plus c, and cos ax is 1 over a sin ax plus c. They're all opposites of what we had in the other table. Yep. All right. So we've already done some examples that have constant multiplier. All right, but we'll look in a minute at how it makes it a bit clearer. The fact that we've got the integral of a constant a times x, you can evaluate it by taking that constant outside the integral and multiplying, and then just integrating the function, multiplying the result by the constant that you took out in the first place. Alright, we'll do sum. We've got a sum rule. If we've got the integral of one function by a function where the functions are the same variable by the way, for example x, we've got f of x, e of x. Take integral of f, the integral of ed. Function. Alright? And then the subtraction rule, if you're going to subtract it, then we take the integral of the first one, the value of the integral of the second one, over. And those formulae for calculus will damn crypto. So, constant when a function constant 1 because constant at the end. So you'll see an example like that, Emma. There should be a plus C in there. Take outside. Time into. Yeah. Equals 3/4 x to the 4. 4 plus yeah. We can multiply the 4's together, can't we? We can say that's 3 4 plus C. Ooh, not 4 plus 4 times 4, which is 16. 3/16 of x to the 4 plus C. Right. Runs on the next page. Constant multiply.
Leave that up.
plus constant outside 3/7. I just want to do something else at the moment. What have I missed out from these integrals separately? Yeah. Over 2. Yeah. Minus 6 x cubed over 3 plus c. Not really. You've got to get rid of the c. But all can be added together to make one big c on the end. Yeah, so you only need one constant. What? From each and make a big difference. We just take them all single constants sitting on their own, all together. Yeah. It is a No, can we integrate that? I'm sure you can. So what's the process here then? We've got to integrate these two separately, subtract the second one from the first one. So what happens when we integrate x squared over 2? Half x to the 3 over 3. Half is the constant multiplier. Like that if you like. Okay. Let's see.
Yeah, where did you get this 3 from?
Which 3? Because that's 3/4 is a constant, 0.75 if you fancy it that way. And when you integrate a constant, as we said on the previous page, when you integrate a constant, it all comes back. Yeah. Yeah. Simplify that. Is that 4 plus c. Right.
This is something we came out with.
Could well do, yeah. B. Yeah. Integral of brackets 1 minus t all squared dt. That is exactly what you need to do.
Squared minus
We got minus t. What do we have to do?
squared
Yeah, which is 1
minus
minus t minus t minus t is, yeah, so that's 1 minus 2t the integral of that. The integral of 1 x is not there, it's not x, t. Integral of minus 2t is minus 2 2 plus
2t.
t to the cubed alright equals minus t squared plus cubed over 3 plus c, which is just given that minus 2 divided by 2. Yep. Alright? Yeah? Determine the integral of what we dx Yep, equals 4 over 3 sine 3x plus c. Second one on that 3, we're looking at the integral of 5 sine 2 theta, 3 theta, yeah, equal the constant times the integral of sine 2 theta, 3 theta. I haven't done that yet, I've still written the integral, look. So I've done up to the constant number, right? Yeah. Minus 1 over 2 cos 2 theta plus c equals minus 5 over 2 cos 2 theta plus c. And always remember, try differentiating back and end up where you started. What I'm going to do now, right, is just going to find it on your notes. On page 18, indefinite integrals, further practice. Start having a go at them. I'm going to pick up next week on next time on indefinite integrals, because if I do a little bit about the day, I'll almost be gone. 3 weeks is gone. Right? We'll be caught up with but I think we're better off to consolidate what we've done here now, that you do the ones on page 18, and then move on and do definite integrals afterwards. Alright? Just background, when you evaluate a definite integral, you know we put some graphs of functions earlier. two limits, and what you're actually doing is calculating the area underneath the function between that and the x-axis. So there's quite a lot of engineering that you can use it for. Find the area of a regular thing. Alright, and we'll be looking at those.